Okay, so today we're going to do probability of day 3, and this is where we're actually going to get started with the probability. So the past 2 days we've done permutations. Remember, that's where order matters, and combinations, where order doesn't matter. I'm just looking how can I group and how many different ways can something be grouped. As we go through these notes, if you start to get the hang of what you're doing, if you want to pause this video at any moment and try something on your own and then go back and see if you did it right, feel free. Okay, so you should have a copy of the notes, and we're going to go ahead and start with number 1. So from a group of 22 nurses, 4 are selected to present a list of grievances to management. Okay, and how many ways can this be done? So this isn't a probability question, this is just in how many ways can it be done. So the first thing you want to think about is this a combination or is it a permutation? Now, remember, a permutation order matters and a combination order doesn't matter. Okay, so sure enough, this is a combination because it doesn't matter how we choose the 4 that are going to be selected. All that matters is that 4 people out of the 22 have to be selected. Alright, so I'm going to try and write on my computer screen, and hopefully it doesn't turn out too messy. So we have 22 people, and we're going to choose 4 of them. Alright, so 22, choose 4. That's all I need to know. That's going to give me 7,315 possible people, and that looks very, very sloppy. So let's try and rewrite that and see what happens. Because first of all, I've got a face as an equal sign. Okay, so equals 7,315. One of the nurses is Michael Branson. Find the probability that Branson will be among the 4 selected. Okay, so that's telling me that there's gonna be 4 selected nurses, but Michael Branson has to be one of them. And here, this is the first time we're really looking at a probability question. So Michael has to be chosen. So out of the 1 Michael, he's got to be chosen. So that's got to be a 1 choose 1 situation. Then I look at how many nurses are left to choose from. Now there's 21 to choose from, and I have 3 more nurses to go. So that's 21, choose 3. Okay. So what I'm looking at is whenever I do a probability problem or a combination like this, I'm looking at, does the top add to the total amount, in this case nurses, so 1 plus 21 gives me those 22 nurses, and does the bottom amount add to how many I'm choosing? So I'm choosing 4 to be selected, right? So 22, 4, we're good to go. Next thing I want to do is divide by the total possible ways that this could have been chosen, and that's what we found in step 1. Okay, so I'm looking at divided by 22, choose 4, which I know to be 7,315. Now, when you type this into the calculator, go ahead and go to that alpha y equals, so you can just set up a fraction and type it in exactly how you see it. Okay, so you'll type in the numerator 1 choose 1, 21 choose 3, all over 22 choose 4. Okay? And when we get that, we get about 0.182, okay, which we know to be 2 over 11. Now find the probability that Branson will not be selected. Okay, so if he's not selected, that means that I have the 1 Michael, and he's not going to be picked at all. Okay, so 1 choose 0. And then out of those 21 nurses that are left over, all 4 of my nurses chosen will come from there. So 1 choose 0, 21 choose 4. Across the top, it adds to the total. Across the bottom, it adds to the number of nurses that I'm selecting. Divided by the total possibilities we had. Okay, so that bottom number, every time we divide when we're doing probability, we're always going to divide by the total possible outcomes there would have been. Okay, so in this case, again, I would go to y equals, type everything in, and when you do that, you get 0.818, which is the same thing as 9/11. Okay, so this is important. The probability that he will get chosen is 2/11. Probability that he won't be chosen is 9/11. You'll notice that both of the probabilities have to add together to equal 1. Okay? If we look at will he get chosen and won't he get chosen, add those together, it should always equal 1. Okay, because my probability is just a percentage. So my percentage should always go back to equal 100%. From a box of 5 white, 7 green, and 8 red marbles, 5 marbles are going to be drawn at one time without replacement. Find the probability of the following events. All red marbles are drawn. Okay, all red are drawn. So the 5 marbles that we're going to draw have to all be red. So I'm going to look at what I have a possibility of. I've got 5 white, 7 green, and 8 red. I don't want any white. I don't want any green. Oh no, I lost my pen. I don't want any green. Okay, so that's 5, choose 0, and that's 7, choose 0. There's 8 red marbles, and I want all 5 marbles that I'm going to draw to be red. So I've got 5, choose 0, 7, choose 0, 8, choose 5. So again, I'm going to look at, does that add to the total amount of marbles I have? Okay, so I'm looking at 20 total marbles. Okay, on the bottom, does that add to the amount of marbles I wanted to draw? Yeah, it's just 5. And then divide it all out by the total possibility that I could have had. So that's going to be 20, choose 5. Okay. Now, necessarily when you have something choose 0, you don't have to write it in. I don't need to see that top part of my numerator is going to add to the total amount. Okay. So you really don't need to write this unless it makes you feel better to write it. Okay. But we know that 5 choose 0, 7 choose 0, anything choose 0 is 1. Okay, so it's kind of understood and you don't need to write it. But type that into the calculator and you should get 0.004. Okay. On number 6, I'm looking at no more than 1 green marble is drawn. Okay, so we could have no more. Well, that means that there could be 0 green marbles or 1 green marble. Okay, so that could be 0 or 1, and that'll give me no more. Whenever I see that or and I'm working with probability, I'm going to be adding the two probabilities together. So what's the probability that no green marbles are chosen, plus what's the probability that 1 green marker is chosen, or marble is chosen? So here I have, how many greens? 7 green, and I don't want any of them. It doesn't matter what the other color is as long as it's not green. So I'm going to look and say there's 5 white, 8 red. Let's see, that's just 13 other marbles. And I want all 5 of my marbles to come from there. Divided by, okay, what's the total outcome I could have? So 20, choose 5. Plus, right, what about if 1 green marble was drawn? Right, so I've got 7, choose 1, and then 13, choose 4. Okay, because I have the 1 green, so out of the rest of those 13 marbles, I want 4 of them. So across the top, that's 20. Across the bottom, that's 5. And I can divide by 20, choose 5. Now a key thing here you might notice is that I have 20, choose 5 as both denominators. So I really don't need to separate these out as 2 different probabilities. Instead, I can take this second one away and really make this one big fraction. So I don't have to type it in a bunch of times. Okay. On 2 green and 3 white marbles are drawn. Okay, so I'm looking at, I need 2 green, so I know there were 7 greens. Okay. I want 2 of them to be green. So 7, choose 2. 3 white marbles were drawn. So there was a total of 5 white marbles. So 3 need to be drawn. Okay, I could look at the 8 red marbles and say 8, choose 0. But again, anytime you choose 0, you don't really need to write it down. You can if it makes you feel better, so that the top will add up to 20 and the bottom will add up to 5, but you don't need to. And again, you're dividing that by 20, choose 5. Okay. put this into the calculator, I should get 0.014. On number 6, no more than 1, okay, that answer, when you type it in, should have been 0.406. Okay. At least 2 red marbles are drawn. Okay, so here we're looking at least. That means that we could have 2 or 3 or 4 or 5. Okay. That's a lot of probabilities to add up, and it sounds like too much work. So I don't want to do it. Okay? Anytime it's too much work, I'm going to figure out another way to do it. So thinking about what we talked about in the previous problem, okay, we said, with this nurse problem, we said the probability that Michael was a nurse or was picked was 2 out of 11. Probability that he wasn't was 9 out of 11. And that always equaled 1. So if we go here and we say if at least 2 are drawn, that's going to be the same thing as if no more than 1 is drawn. Okay? So I can do 1 minus less than 2. Okay? Less than 2. So 2 is not included in that. So I'm going to do 1 minus, okay, at least 2 red marbles. So let's say, okay, there's 8 red marbles, so there's 12 other colors. So I want all 5 of the colors to come from those 12, or marbles to come from those 12. And then I'm going to add that to, okay, so that's probability of 0. Now let's add that to the probability of 1. So I'll have 8, choose 1, and 12, choose 4. All over all the possibilities, 20, choose 5. Okay. And I'm taking 1 minus this whole thing. So I would go ahead and maybe type in that fraction. I know it's written pretty poorly. Hopefully yours looks better and you can actually read it. Type in this whole thing and then do 1 minus your answer. Okay? And when you do that, you should be getting 0.693. Okay, 0.693. All right, so you're looking at it was 1 minus 0.307. Okay, so when I type in this big fraction, okay, with the 12 choose 5 plus 8 choose 1 times 12 choose 4, all over 20 choose 5, I should get 0.307. 1 minus that, okay, so the probability that at least 2 are drawn from this pack is 0.693. Whew, man. Okay. Something long to read. When shipping diesel engines abroad, it is common to pack 12 engines in one container that is then loaded on a rail car and sent to a port. Suppose the company has received complaints from its customers that many of the engines arrive in non-working condition. To help solve this problem, the company decides to make a spot check of containers after loading. The company will test 3 engines from container at random. If any of the 3 are not working, the container will not be shipped until each engine in it is checked. Suppose a container contains 2 non-working engines. Find the probability that the container will not be shipped. Okay. So there's going to be 2 different ways to do this. For it to not be shipped, okay, we need to have 1 or 2 non-working engines. So out of that sample of 3, okay, if any 3 are not working, so we're only going to test 3. If any 3 are not working, okay, that's going to tell me, hey, we're not shipping. So here we're looking at, suppose a given container contains 2 non-working engines. Find the probability that it will not be shipped. Well, there's 2 things to do. We could say that our sample, okay, out of those 2 non-working, 1 of them is going to get picked in my sample. Okay, as long as 1 of them is going to get picked, then we're not getting shipped. Any of the 3 that are picked won't be shipped. Okay, so that means that the other two, okay, the other two chosen at random are not going to be picked. Okay. Plus, okay, so we're looking at 1 or 2 are not working. Okay, so there's the probability that one of the two that aren't working are getting picked. Okay, what if both of the non-working are picked? Okay, both of the non-working are picked. Okay, so that means out of the 10 that are working, one of them will be picked in my sample group. All over, okay, that comes to a total of 12. Again, we had 12 engines right there. 12, choose 3. Any combination that could have been chosen. And if we do that, we get 0.5455. Okay, so let's look at another way. Let's see. Okay, that was one way to work it. Let's look at another. Let's look at 1 minus the probability that this actually gets shipped. Okay, 1 minus the probability that this pack gets shipped. Well, the probability that this gets shipped is if all 10, okay, or if all 3 of the ones that are picked come from the 10 that are working. Okay, so 2 were not working, the other 10 in the set were working. So our sample size of 3 that we have to check is going to come from all of the working ones. So what's the probability that that happens? Over 12, choose 3. 1 minus this. Okay, if we work this into our calculator, you should be getting 0.455. So you'll see we get the same answer no matter what. Okay. Lots of different ways to work it. Well, 2 different ways. Okay. Poker. Okay. If you're not up to date on your poker rules, you're going to learn how to play poker in this unit. So a poker hand has 5 cards. Find the probability of each of the following. Okay. 1, a hand contains only hearts. So some things about cards that you're going to need to know. You need to know that there are 52 cards in every deck, and you need to know that every hand, okay, so that's going to be, or not every hand, but every suit has 13 cards, and our suits are our diamonds, our hearts, our spades, and our clubs. Okay, so a hand containing only hearts. Well, there are 13 hearts. Okay, so out of those 13 hearts, I want all 5 of them. Okay, again, I can, but I don't have to. I can list the 13 spades, choose 0. The 13 diamonds, choose 0. The 13 clubs, choose 0. Okay, but because those are all choose zeros, I don't actually have to. So I'm going to divide this by the total amount of cards that I could have, that I could just randomly pick. So out of the 52 cards in a deck, any 5. Okay, so type that into your calculator really fast. And you should get a really, really small number, like 4.952 times 10 to the negative 4. Okay, a full house of aces and 8s. Okay. A full house is when I have 3 of one card, so let's say I have 3 2s, and then 2 of another specific card. So I have 3 2s and 2 5s. That would be a full house. Okay, so I'm looking at a full house of aces and 8s. Now, let's look at it first as, what if I had 3 aces? So out of the 4 possible aces I have, I'm going to choose 3 of them. Okay, and then 8s. Out of the 4 possible 8s there are, I'm going to choose 2 of them. Right? Another way I could have done this is What if I had 3 8s and 2 aces? Then again, I would have 4 choose the 3 8s times 4 choose the 2 aces. Well, I already have 4 choose 3 and 4 choose 2, so I'm just going to multiply that by 2. And I'm going to divide it by the total possibility of cards. Okay. So 2 times 4 choose 3 times 4 choose 2 over 52 choose 5. Okay, so go ahead, type out in your calculator really fast. Okay. And you should get 1.847 times 10 to the negative 5. A flush. So that's going to be 5 cards of the same suit. So a flush, 5 cards of the same suit. They don't have to be in order, they just have to be all the same. So let's say number 9, for example. Number 9, what we did here, that's some kind of flush. So we had, hey, there were 13 hearts. My hand had all 5. And I divided that by 52, choose 5. But there's a catch here. It didn't necessarily have to be hearts. It could have also been the diamonds. It could have also been the spades. It could have also been the clubs. Okay, so there are 4 different decks. So I'm going to go ahead and multiply this numerator by 4. And it's the same thing as if I had added. If I'd said it could have been hearts or diamonds, which means I would add the probability of 13 choose 5 plus 13 choose 5, or clubs or spades. So I would be adding it all the time, same thing as multiplying by 4. Okay, and when I do that, I should be getting 0.002. Okay. This time we're looking at any full house. Okay, any full house. In number 11, it had to be aces and eights, but here, anything will do. Okay? Well, I know a full house has 3 of one kind and 2 of another number. So I have 4, choose 3, and 4, choose 2. Right, but there's a little catch. Let's say I get all these 3's first. It could be any number, right? And there are 13 different numbers. So I'm multiplying this 4 choose 3 by 13. Well, once I have that number, let's say I got 3 2's. Once I have those 3 2's, for the part where I have 2 of some number, they can't be 2's because those have already been chosen. So there's 12 possibilities for what I could get next. And then I would divide that by all the hands that I could have been dealt. 52 choose 5. And that time I should get 0.001. Okay. Last 2 problems that we have. Okay, so you're running for office against 4 other people. Find the probability of the following. Your name is the first on the ballot. Okay? One thing that's really key here, first. If your name has to come first, that doesn't mean we just randomly chose a big group. It means that order has to matter here. So I'm running for office against 4 people. Find the probability that you come first. Okay, so how many other people are running? There's you, 2, 3, and 4 other people. I want my name to come first on the ballot. So this is just talking about the order in which, when we have our ballot, whose name is written where. Okay, what's the probability that my name comes first? Well, there's 1, and then the rest doesn't matter to me. I don't care. So there's the 4 other people, then 3, and then 2, then 1. But this is a probability problem. I'm not asking you how many different ways could this ballot be written. What's the probability that I'm first? Okay, so anytime we have probability, we're dividing, okay, by all the possible ways. So there's 5 of us running for office, okay? Any 5 of us gotta come first, and then any 4 of us, then any 3, 2, and 1. Okay, so this is what I'm gonna need to type into my calculator. And when I do, I see that the odds are 1 in 5. Your name is first or second on the ballot. Okay, so your name is first or second on the ballot. Well, we know the odds of me coming first is 1 in 5. Anytime I see or, I add. Okay, so this time, probability that I come second. Okay, if you already see it, that's good, but if you don't, let's kind of go through it. Remember, there's you and 4 other people. So you want to come second. Okay, so you're the only option for that second part. There could have been 4 people, then 3, then 2, then that last lonely guy, divided by all the options. So really, this came out to be 1/5 plus 1/5, so the probability was 2/5. And we're done. So hopefully this worked out and you kind of followed along. You have the homework for you to work, and on Monday, y'all are just gonna have a practice day. So a day of practice with your partner. So with that, have a great weekend. I'll see y'all on Tuesday. If you have any questions, email me and I will try to respond. But hopefully it went well.